Alright, here we go. This is going to be the first Algebra 2 video for this year, and the lesson is models of parent functions. Now, it's going to be really important for you guys to understand these are parent functions. These are just the basic formulas for each shape that we're going to be working with throughout the school year. Later on during the year, we're going to learn how to do transformations of parent functions. Transformations means it's shifted around. It's moved left or right, or up or down, or it's flipped upside down, or it's steeper or flatter. For now, we're not worried about transformations. For now, we just want to learn the basic shapes of the different types of graphs. So we're not going to worry about shifting or flipping or anything right now. We're just going to look at the parent function basic shapes. For Algebra 1, you only had two types. The two types of parent functions you had for Algebra 1 were linear and quadratic. For Algebra 2, we're going to add 5 or 6 other types. So it's way more complicated for Algebra 2. And it's going to be really important you understand these different shapes. And that's why I'm taking the time to put this video up so you can go back and review anytime you need during the year. So let's go through these different types, look at the formulas, look at the shapes of the graphs, and try to make sure we understand the differences between these different types. So let's start off with this linear parent function. For the linear parent function, the base formula is y equals x. So whatever value you substitute in for x has to exactly match the y value. So the shape of this graph is running diagonal from the bottom left through the origin to the upper right. And you want to make sure you understand the arrows on the end of those means the graph keeps on going. It doesn't stop at the edge of the picture. So what are some of the basic properties of this linear parent function here? Well, the linear parent function is always increasing. It moves up to the right. Linear obviously means it's a straight line. All of the other parent functions curve except for absolute value, and we'll get to that later. The linear parent function is straight, and that makes it easy to pick out in problem situations. It's a straight line. What are the domain and range of this linear parent function going to be? Hopefully you remember from Algebra 1, domain is the set of all x values. So for this linear parent function y equals x, what can x be? If you look at the graph, we can go as far left or right as we want to on this graph, can't we? So the domain of the linear parent function is going to be all real numbers. From negative infinity all the way to positive infinity. Any x value we want to pick is going to be on that graph somewhere. What's our range going to be for the linear parent function? Hopefully you remember the definition for range is the set of all y values. So what y values can we have? If you look over at this graph, the y can go as high or low as you want it to. That's what the arrows mean. So the range is also going to be from negative infinity to positive. Y can be any value. X can be any value for the linear parent function. The key to this shape is it's a straight line. When we look at quadratic, the formula for the quadratic parent function, y equals x squared. What makes it quadratic is that x to the second power right there. The shape of the quadratic parent function is a parabola shape. It's this kind of U-shaped curve. The parent function does pass through the origin for the quadratic parent function. Notice to the left of 0, when the x values are negative, the quadratic parent function decreases as you get closer to 0. On the right side, for the positive values for x, as you move to the right, the quadratic parent function increases. That's different than the linear parent function. The linear parent function always increases. The quadratic decreases for a while and then increases for a while. And it curves instead of being straight. What's the domain of the quadratic parent function going to be? What x values can we have? If you look at the graph over here, when we include the arrows on the end of the curve, how far left can you go? Go as far left as you want to. How far right can you go? The arrow in the end means you just keep on going. So you can make x as large as you want it to be. So the domain of the quadratic parent function is similar to the domain for the linear parent function. X can take on any value. Is that true for the range? What y values can we have? Can it be any number? And the answer here is different. Y's cannot take on any value. The lowest y value that we have is y equals 0. For the range of the quadratic parent function, we don't have any negative y values. How large can the y values go? The arrows point off the top of the curve. The y can be as big as you want it to be. All right, let's move on. The square root parent function. First thing I'm going to tell you is square root is actually graphed and can look something like this. It's the inverse of the quadratic function. Notice, if you look at the square root graph, it's not a function, because for this individual x value, we have two different y values that match it. So to make the square root parent function, what they do is only include the positive side of the curve. So if we go back to your handout here, for the square root parent function, notice it only includes the positive half. If you're solving problems and you take a square root, it's important that you remember the square root could be positive or negative. But for the parent function here, they're only graphing the positive side, so it will be a function. Look at the shape of the square root parent function. How is it different than the linear and the quadratic parent function? Well, one obvious difference is right here. It has an endpoint. It doesn't keep going. And that endpoint is at the origin for the parent function for the square root. What else do you notice about this shape? As you move to the right, you're always moving upward. So the square root parent function is always increasing. Let's look at domain and range. What's the domain of the square root parent function here? What can our x values be? notice our x values can't be negative, can they? We don't have anything on this side. So the furthest to the left we move is when x equals 0. How far right can we go? We can go as far right as we want to. So the domain of the square root parent function is x has to be greater than 0. No negative x's. If you try to take the square root of a negative number, it's going to produce what's called an imaginary answer. We're going to talk about imaginary numbers much later on in the course. For now, we're only looking at real solutions. So we're only going to look at square roots of positive numbers at the beginning of the course. So our domain only includes the positive values for x and 0. What's the range of this square root parent function going to be? What y values are possible? If you look at the graph, what's the lowest you go? The lowest y value we have is y is 0. Everything else is above 0. So the range of our square root parent function is the values y have to be greater than 0. You can go as high as you want. If you go back and look at these first three parent functions, the shapes are all different. Linear is a straight line, quadratic decreases and then increases. Square root always increases, and it curves. If you look at domain and range, you're also going to notice the domain and range are different for each of these three parent functions. So the shape of the graph, the formula, and the domain and range are going to be different. And that will help you when you're trying to decide which shape a graph is on a homework assignment later on. The next type of parent function that's discussed here is called the rational parent function. Back when I was in school, they called this the inverse parent function, because we're dividing by x. It was called an inverse back then. Now they call it rational because it's a fraction. You can see the formula is a fraction, y equals 1 over x. Okay, the shape of this rational parent function is totally different than any of the other parent functions we're looking at. And it's not hard to see what's special about this rational parent function. It has two distinct portions. And they do not connect. Two separate pieces of the curve. When you divide by a negative x value over here, you're going to produce a negative y value. In the third quadrant, the x's are negative and the y's are negative. When you divide by a positive number over here, your result is going to be a positive number. So the rational parent function is stuck in the first and third quadrants. It is broken into two parts, and the two parts do not connect. If we look at the domain and range of the rational parent function, there is something special about those as well. If you look at the domain of the rational parent function, what x values can you have? Well, the x can go as far left as you want, and the x can go as far right as you want. But you've got to be really careful, because nowhere on this rational parent function does it touch x equals 0. Over here on the left side, we get closer and closer to 0, but we never get to it. On the right side, we start off really close to 0, but the graph never touches x equals 0. So to list the domain, I'm just going to put x cannot equal 0. You could write it as two pieces here, and that would be just fine. We can include all the negative values, not including 0. We can include all the positive values, and again, we're not including 0. It's just a lot easier to write it this way. X can take on any value except x equals 0. What's the range going to be? What y values can you have? Well, down here the graph continues going lower and lower and lower. Up here the graph goes higher and higher and higher. But what's missing? Again, what's missing is this y equals 0. The rational parent function never touches y equals 0. So the simple way to write the range is when y cannot equal 0. Or you could write it in two pieces. Like that. Y can take on any value except 0. X can take on any value except 0. The rational parent function is broken into two pieces. For the parent function, it's first and third quad. So again, for this parent function, the shape of the graph is different from the other three. The formula is different from the other three. And the domain and range are different from the other three. The next type of parent function that's shown is what's called the exponential parent function. It is called exponential because our x value is in the exponent. Exponential because x is in the exponent. There are two types of exponential functions. When the base value is greater than 1, you're multiplying by a number bigger than 1 over and over and over again. So what's going to happen? The values are going to increase rapidly. If the base value is between 0 and 1, you're repeatedly multiplying by a value between 0 and 1. So the values are going to get smaller and smaller and smaller. Some students confuse exponential graphs with quadratic graph. So let's go back and look and see why they're different. What do you notice about a quadratic? This part of the curve looks kind of like the exponential. But how about over here? Quadratic goes back up on the negative side. Does the exponential do that? No. On the negative side, the exponential decreases as you move further left. The quadratic parent function decreases as you move closer to 0 and then increases on the other side. The exponential parent function is always increasing. The important thing is to make sure you look at the whole graph, not just half of it, okay? what's the domain of this exponential growth curve? What x values can we have? Well, x can go as far left as we want it to. X can go as far right as we want it to. So the domain is all real numbers. What's the range of this exponential growth function? What y values can we have? Notice our y never dips below 0. All of our y values are positive. So the range of our exponential growth function is y has to be greater than 0. But y can go as high as we want. For what's called exponential decay, where the values are decreasing to the right, what would our domain be? X can go as far left as we want it to go. X can go as far right as we want it to go. So the domain is all real numbers. What's the range? The range of the exponential decay function is going to be what? What y values can we have? Notice all the y values here are greater than 0. And we can make the y value as large as we want it. So the domain and the range of exponential growth and exponential decay are the same, but the shapes of the graphs for decay and growth are different. Exponential growth function increases to the right. Exponential decay decreases to the right. And it's not even close to the same thing as quadratic. All right. Logarithmic parent function. Logarithmic parent function does include a logarithm. Look at the shape of the curve over here. Does it look familiar? Last year, some students really got confused when we were comparing this logarithmic graph to the square root parent function here. But there is a significant difference in these two curves. Compare this square root graph to this logarithmic graph and see if you can figure out what the difference is. Okay, hopefully you noticed that the square root parent function starts at 0. What is the x-intercept for the logarithmic parent function? It's over here at x equals 1. What else is different about those two curves? The square root parent function starts at 0 and increases.
Miss Muncy, can you come to the office,
Like this.
please, Miss Muncy?
But how about the logarithmic parent function? The square root function stops. Does the logarithmic parent function stop at the x-intercept? And the answer is no. The logarithmic parent function continues. So this piece right here is really significant in order to be able to tell the difference between square roots and logarithmic graphs. The range is also different for these. I'm going to look at that in just a second here. Okay, so what's the domain of the logarithmic parent function going to be? What x values can we have? Notice for our logarithmic parent function, we never cross over into the x's are negative. And also notice we get closer and closer to x equals 0 down here, but we never touch x equals 0. If you take the logarithm of 0 in your calculator, it's going to give you an error. So what's our domain for our logarithm function going to be? X has to be greater than 0. And x can go as big as we want it to. What's our range for the logarithmic parent function going to be? What y values can we have? Down here, y goes as low as we want it to. And over here, y is going to be higher and higher. So we can have any real number for the y value for our logarithmic parent function. This range is different than the square root parent function. The square root parent function did not include the negative y. All right. The last parent function that we're going to look at here for Algebra 2 at the beginning of the year is called the absolute value. The absolute value is these vertical bars on both sides of the x. And what absolute value means is just how far are you from 0. How far is x equals negative 1 from 0? It's one spot away. How far is positive 1 from 0? It's one spot away. We're not worried about the direction, left or right, positive or negative. We're just worried about the distance from the origin, the distance from 0. So the absolute value function does not include negative y values. The linear parent function continues down this direction. The linear parent function included the negative y's. The absolute value function does not. We don't care that it's left. Negative is down. The absolute value function is a sharp V shape. Don't confuse that with the quadratic parent function, which is a curved U shape. Sharp V shape here. Comes down, touches the origin, goes back up. Decreases for negative values for x, it increases for positive values for x. What's the domain of the absolute value function? What x values can be included? X can go as far left as we want it to. X can go as far right as we want it to. So the domain of absolute value is all real numbers. What's the range of the absolute value parent function? What y values can we have? We come down and touch y equals 0. So y is going to be greater than or equal to 0. and the y values can go as high as we want them to. So the range of all y's greater than or equal to 0. Those are the base parent functions for the different shapes of graphs and the different types of formulas we're going to be using in Algebra 2 throughout the year. It is very important that you notice the formulas are all different. The shapes of the graphs are all different. And the domains and ranges do not match. Feel free to refer back to this video throughout the year, especially when we start discussing the transformation rules for these different types of shapes. I'm going to leave this posted on the home page on my web page for Algebra 2, so you can look back at it anytime you need to. And you can pause or fast forward through the video to get to the section you need at any given time during the year. I hope you find the video useful.